Hi everybody, in this video I wanted to talk about slope and in particular what slope means. So the slope of a line always represents some sort of a rate of change, and the y-intercept always represents some sort of initial or a base value. So for example, here's some graphs, and we like to find the slope and interpret the slope as a rate of change. Also the y-intercept is an initial value. So when you read this graph, the x-axis down here is the time, the number of years of use, and then my y-axis is the value of a computer in hundreds of dollars. So in this case our y-intercept times 0 is $3,000 or $3,000 that would be. So my y-intercept is $3,000, and that's the initial value of the computer. All right. For the slope, notice that if I went from this point to this point, it looks like each of these are about $300 here. So I'd go down, 27, 24. 21, so it looks like it's dropped $900 here in 1 year, right? So this would be a rise of negative 900 and then a run of 1 year. So in that case my slope, thinking about the units here, is negative $900 per year, and that would be my rate there, right? So that would be a negative $900 per year that computer is decreasing in value. So we'd call that the depreciation. Okay, so that's an example of a rate of change. It's the value of the computer is changing at the rate of $900 per year. Here's another one. Here is the x-axis is the number of minutes spent running, and my y-axis is the distance from home in kilometers. So notice at time 0, it looks like we're 5 kilometers from home. So that would be my base or initial value in that case. And then my slope, when I go from this point to this point, I'd go a rise of 1 kilometer in 4 minutes. So my slope would be 1 kilometer in 4 minutes, and notice that's a rate. I could think of that as 1/4 kilometer per minute. That's a rate. That's how fast that the person would be running. Okay, and again the y-intercept would be 5 in this case. That's the initial distance from home. Let's look at a couple more problems here. Each of these functions is of the form y or f of x equals mx plus b, and we want to think about what the slope m and the y-intercept b signify. So it says that each salesperson at Nobby's Furniture is paid so many dollars per week, where the function p of x, like pay of a function of x, is 0.05x plus 200, and x is the value of the salesperson's sales for the week. So it looks like if I plug in 0 here, that would give me 0 right here. I'd get 200. The 200 is my y-intercept, and notice that's going to correspond to how much money the person is going to make, even if they don't sell anything. Remember, x is the value of the salesperson's sales. So even if they don't sell anything, they're still going to make $200. So my B in this case would be $200. That would be the base pay. That's how much they get paid, even if they don't sell anything. And then my slope here would be 0.05. And so if they, for example, sold $100 worth of things, then they would get 5% of that. And so this is a commission. So that would be the rate of commission that they're being paid. So again, the slope is always some sort of a rate, and the y-intercept is some sort of a base amount. Okay, here's another example. Cost of running a truck. The cost in dollars of a one-day truck rental is given by C of D. The cost is a function of D, where D is the number of miles driven. So in this case, my slope, or my y-intercept B, is 20. That would be $20, and that's how much it's going to cost to rent that truck, even if you don't drive it at all. If you just want to sit out in the parking lot and listen to the radio, it's still going to cost you $20. Okay, so that would be the base amount for the rental. And then my slope is 0.3, and that's going to be the number of miles. So if we drove 100 miles, you'd multiply 30 cents, $0.3 times 100 miles, right? That'd give you a $30 for the mileage. And so this is a rate per mile. So again, the slope is a rate, and then the y-intercept is a base amount. Okay.